Hello and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and so this week we're continuing with the banking on Clojure project that we've been working on, creating a web application backed with a database using some Clojure specs, and it's going to provide us with a server-side web application for a very simple banking app. So this week we're going to continue using SQL, or trying not to use SQL, and trying to use Clojure data structures instead. Oops, I've gone blurry. There we go. And so trying to make it easier to work with SQL, especially if you haven't used SQL very much. We can use Clojure to generate our SQL statements for us. Let's see, is it all working? It's working today. There we go. So just before we start, a reminder, there's a Practicalli website, practicalli.github.io or practical.li. And I'm still working on the Clojurists together. They're still sponsoring me to do more content work, so I'm getting a lot more done, which is much appreciated. Thank you for everybody who voted for me. We've got all the videos, we've got the books. So I've been doing some updates in Clojure web apps this week around the friendly functions from next.jdbc, which we're going to cover today. And I'm also doing a lot more work on the Practicalli Clojure. There's some interesting changes coming up for Clojure CLI tools. So I'm trying to understand the kind of changes that are taking place here. So we've got some new flags. So the M flag to run anything with Clojure main. So this is a bit more kind of open and free form, how you run a Clojure project using strings on the command line. And then there's a new Clojure exec. So we've got exec function and exec args. And so this allows you to run your application or Clojure tools and specify the configuration using a nice Eden data structure, specifically a Clojure hash map. And so this is kind of like a very nice approach to be able to use Clojure data to configure Clojure applications. And so you see this option being adopted a lot more, hopefully, in the future. And then there's also P alias, which basically allows you to run your command to either run your application, to run your application or to do some task, but not actually run it, just prepare it, just to do a dry run. And it's especially useful for doing CIs. So if you wanted to do the equivalent of line deps, you can use the P command, the P flag to say, well, I want to do it, but I just want to download all the dependencies before I actually do it, just to make sure it's going to do what I expect it to do. So I'm going to do some videos on that. So it's taken up a bit of time this week. It's still not quite out yet. It's still early release, but I'll do some videos over the next few weeks on the new changes in more detail. And if you want to reach out to discuss anything that we're covering here, or if you want to ask questions just about Clojure development in general, you can always reach out on the Practicalli channel. And there's also many other useful channels on the Clojure in Slack. And again, there are ways to support me and motivate me. I think we're nearly up to 700 subscribers on YouTube. So if you haven't subscribed yet, then that's always a nice little boost. And if you want to financially support me as well, then there's options there as well. Okay, let's get on with it. I'm sure it's a Monty Python sketch somewhere. Okay, so I've been adding some work to the Clojure web apps. So we open this then. So this section. So I've got some general kind of architectural components here. So the application server, application logic, and relational database. So I've added some more content to H2. I put this schema design. So looking through, I had kind of a decision when I was building my apps. So in the database queries, which we set up, which we covered previously, in the database tables, we've got the 3 tables for account holder, account ID, and transaction history. And so these have IDs, and how do we best represent those? So unique IDs, you can use a universal unique ID, a UUID type, which we've done here. But databases can also support like doing incremental values, so that when you actually add a record, you don't provide the value, you just get the database to increment it for you. So in the example in the accounts table, we've got the account ID as a UUID, but the account number, which is like the visible number for the account, the number that appears on your credit card or debit card. This is set up to be an auto increment one. So when you add a record, then it'll just automatically increment to the next available number that's not in the database. So this is quite a handy feature. But the auto increment is kind of like the old style of doing things. So I'm going to change that to use identity, which it seems to be the new approach that most people are doing. So I'm just going to check that that's going to work in all of the databases I'm going to use. So I'm using H2 database, which it says is okay, and I'm sure that's probably the same in Postgres, but that's something to check. And so therefore we can kind of just use identity rather than so in here for our ID, we've got identity rather than the auto increment, which does exactly the same thing. And so when we do an insert into our table, we don't need to pass the value for the ID because that's automatically included. Excuse me. Sorry, I still got a bit of a cough. So there's that little bit to update. So I'll feed that into the banking on Clojure next. And then there's an interesting article I found, which is whether to use UUID or some kind of group IDs, and whether to kind of use auto increment instead of that as well. So there is some potential kind of downside to UUIDs for performance, because they're not in sequential order. So building an index for, if you've got a huge number of records and you're indexing them by the UUID, then you might get some performance hits. But if you're sharding, then UUID can be much more efficient for you and can be easier to work with. So I'm going to have a think about those things and see what they kind of identify, kind of list of pros and cons really, and put that into the book. For now, then, I think using UUIDs for our IDs is fine for now. We're not shipping live just yet, and there's a lot of performance testing to do anyway around that kind of thing. So, are we using the database correctly? Is it a bottleneck? And we haven't even got connection pooling on yet, which is also another potential bottleneck. I don't think I've added anything else. No, that's it. And so back to the banking on Clojure application. If you've got any questions, feel free to put them into the chat. Ooh, we've got lots of people watching. And so we've got a lot of stuff done here. Still lots to do. We've got the database tables pretty much designed. And then I've been looking at the database queries. So in last week's video, we covered all the kind of database design and all the schemas that we've created for each of the 3 tables. So we don't need to cover that. And then how do we actually execute our queries? How do we do our crud operations? And in case you're not familiar with crud, then if you look at Wikipedia, we've got this create, read, update, delete. It's just a general term for an application. So you create a record in a database. So from a web application point of view, you're doing a put or a post, perhaps using a form to create a new account holder. So you've got a new customer. Hello, thank you. And then so that is like an insert in SQL, and it's a put post in our ring environment, in our Clojure environment. And then we got read, update, and delete. Excuse me a second. I really do have a bit of a cough. Hope everybody else is feeling okay today. Yeah, so we've got crud. It's a fairly common term, and it just gives us a nice way to kind of logically think about what's going on in our system. So we're covering these things today as they apply to SQL and how we do those in Clojure, and trying to do those as Clojure-y as possible. Let's get rid of that. Boom. Boop. So different approaches we could take. So I found it very useful to use the dbbeaver tool. So if I just start that up, dbeaver. So this is a free database management tool, which is locked somehow. Oh, I've got it on a different. I got it on a different. Oh, there it is. There we go. I already had it open. There we go. So we've got dbeaver, and this allows us to browse our tables, and it also allows us to create, generate SQL for us. We can generate our select, insert, update, delete. Ooh, merge. I didn't notice that before. What does that do? And it generates a nice kind of preview of what it is. So this is good. Yes, because I was thinking whether there was a way to do this. And so dbeaver is really useful for checking what databases can do, because it gives you lots of defaults across all databases. So the things I'm trying out now, generating SQL, I can compare the SQL it's generating for the H2 database with the Postgres database I've got here as well. So this is a remote database running on EC2, running on Heroku, and we've got our schemas in here. So it's slightly differently organized, so it helps us understand the organization of the database. But I can also go and look in there and generate stuff, and it's only generating. Oh, that's wrong one. There we go. So if we have a look at account holder, we can generate that and see if yeah, it does have a merge, and we can then compare the 2 pieces of data that it generates to SQL statements it's generating, and see if they're the same for the same database. So although SQL is a standard, the implementations aren't always guaranteed to be 100%. So there are sometimes tiny little changes between databases, but in the main, like certainly conceptually, they're all the same. But it's always good to check to see whether the same SQL works across all the databases that you're actually using. So if we go to our just go down to the bottom of this page. I'm just going to paste that. So as well as the create, update, create, read, update, and delete, this has got what it calls a merge. I've seen this called an upsert. And it's really a combination of the insert. Lose my voice, sorry. So it's a combination of the insert and the I think and the update. Yeah, the update. So if you're not sure if a record exists, you can use this merge, this upsert, and it will update if there's an existing record, or it will insert if there's no match found as well. So it's a nice way of minimizing the kind of checks you'd have to do. So if you didn't have this, you'd have to go off and get the results. You'd have to read the results, check to see whether there was a matching record, and if there was, you'd then do an update, and if not, then you would do an insert. So if you use this SQL, then it's going to do that for you. So that's something you can have a look at in changing or adding to the crud. I suppose you could have crud with crudum. I have to change the acronym a little bit so it makes more sense, but there we go. So that's some homework too. So it's useful if you're not very good at SQL, or if you haven't used SQL for ages, like me, then it's a very useful tool for exploring, seeing what the state of the art is and what the kind of general recommendations are, best practices are for that as well. I'm going to disconnect, just because that's connected remotely. I'm definitely going to disconnect this one. This is the actual H2 database that we're using locally. So I'm going to disconnect that just to make sure that I can still talk to my database via my REPL. So otherwise, if we get both connections there with the H2 database, it's only going to have one connection, so it's going to lock them, which I don't want it to do. Okay, so we've got the so how do we put all these queries into our Clojure code? We have been using the next.jdbc execute function to drive all our code for creating and viewing and showing the tables, and also dropping the tables. And it's a very handy generic function to run some SQL. We could also define our own generic function. There's some next.jdbc.sql functions we're going to look at, and then creating a nice generic function using those functions as well. So we're going to have a quick look at those options. Spoiler alert, we're going to use this at the end. So we can get some information from DB for how our SQL statement should look. We can create, using the JDBC execute, we can just create our SQL statements in here. And you can see we're actually doing, because we're passing in some information like the account holder information, the account holder ID, we're using string, just a simple, the Clojure call string function, just to be able to concatenate this into a complete SQL statement, which is okay. It's nice and simple, but it gets a little bit messy. And then we can just call the account holder function with our generated data and the database specification, which is used to create the connection, and then just execute on the connection the semi-dynamically generated SQL statement. So it's pretty simple, and you can see exactly what it's doing. And we could make that quite a generic approach, just a database update. So we're taking in a kind of SQL statement and the database spec, and we're just basically going to use a connection to pass in the SQL statement. So that way we don't have to hard code in the SQL statements into the specific functions, and so we can use them over and over again for all the SQL statements we want. We can put SQL statements into defs and give them names, although if they're going to have generated data like this random UUI, you'd need to reevaluate the def each time you wanted a new value, because otherwise it's going to cache that value as well. So it's defs kind of be a quite convenient way to hold it's like several kind of data sets of SQL statements you want to run just to test out the database design. But there is you do have to be careful that you're not, if you've got randomly generated data, that's you need to make sure you're evaluating this def function each time, because if we just evaluate this function to call database update with account holder Jenny, then it's going to use whatever this function you evaluated to the first time. It's going to cache that and it's going to reuse that each time you call this expression. But if you evaluate this expression each time, then it's going to generate a new UUID. So it's handy in the REPL, but obviously we're not going to do that when we're running the application live. There's much better ways to do that, and which we'll come across, things like migrators. The downside is we're still dealing with strings and doing string manipulation here, so we do need to be careful in how we put these things together. We need to make sure we're creating a string, and to satisfy the next.jdbc syntax, we need to make sure that string is also inside a vector. So it's easy, simple enough, but it's not necessarily a Clojure approach. And so there is the next.jdbc SQL namespace inside the it's inside the same next.jdbc project, and this allows us to use a Clojure data structure to generate the SQL. So in here we're doing an insert, which is from this next.jdbc SQL namespace. We're taking a data specification and the table name. So we're going to do an insert over a connection on the table address table, and these are the columns that we're going to update. So we're going to update the name and email column. So we're going to create a record essentially with the column name is going to be a person and email is going to be albert@person.org. And so we can put that into add account holder for the banking on Clojure project, and so we can use so we can pass we've been passing the account holder ID in there and the data source. So that's the database specification, and it's going to basically create an insert, and then we can specify which column names we're populating. So all the database columns that are required, we need to put a value in there. But this is just a key value pair. So let's look at an example. So we've got our DB spec we're passing in. So we're going to get a connection with the DB spec, and we're going to manage that connection using the with open function. And so this, as we saw last week, this closes the connection once we're finished, so make sure everything's nice and tidy afterwards. We're not using a connection pool yet, so we do need to close the database connections when we're finished. But essentially we're doing a JDBC SQL insert on the connection on a particular table, and then our SQL statement is just generated from this map. So it's a lot more simpler if you're familiar with Clojure rather than SQL. And we're still calling it the same thing here as well. So we're just passing in a random UUID, which is going to go into there. And so there's no string building, and then so it's a lot easier to substitute values in here. And we can also pass in a Clojure map, as it were, so we can generate that outside of this function as well and make it even more generic, which is strangely what we did next. So I've defined this insert record, which is a generic insert function, and so we're passing in a table, a database spec, and the record data. So the actual data we're going to use to create to insert a new record. And then that just runs insert on the connection for a particular table and with our record data. And then, yeah, so that's a lot simpler. So we can have an insert record and an update, a delete, and a read record. And so we can have a crud. We can have like 4 different crud functions, and they're just wrapping that. And so if we then move from starting and closing a connection, if we then move to a connection pool, then we just need to update these 4 functions to use the database pool, and then we're done. And an interesting thing is when we kind of pulled out this information, when we made this more generic, we essentially pulled out this map and replaced it with the record data. But if we actually look at the record data by itself, it actually looks very much like the specifications that we actually created way back in the towards the start of, well, even before we started this project. We created a bunch of banking specifications, which were already defined. So we create all these banking specifications here. So it's very much looks like those. So we could actually use those to generate some mock data for us as well. So we're going to try and see if I can fit that in today as well. So we've got our design, so there's a few options there, and we're going to plump for the, let's just jump up there, we're going to plump for the generic function using SQL, using the next.jdbc SQL functions. So we've got create, read, update, and delete records. And then, so calling these kind of the more general crud names, then that helps us relate that to what we're trying to do when we tie these up to our web application and handlers. We can just call create record, read record, update record, and so on. And so we can just call these functions from our handlers, and it provides a nice abstraction over how we're using the database itself. So the create database records. So we've got create record. So this is basically doing an insert. So we're doing a JDBC insert, and we've also included SQL at the top. So let's have a look at these in code. Boop, there we go. So this is our database access namespace. So this is our database access file. And we've already got, I think we already added this. Oh yeah, so we've already got JDBC, so that's the main next.jdbc library. We added specs in so we could put some instrumentation on our functions just to make sure that we're passing the right SQL statement forms. And then we're also using this next.jdbc.sql, and I've just given that an alias of JDBC SQL. And so then we can use the friendlier Clojure specific functions. So we've got the database schema, we don't need that. Boom, boom, boom. So we've got 3 schemas in here. And then we've got kind of helper functions we've done already. So we've got create tables, so that'll create all the database tables for us. And then we can do show and drop, so we can see whether they've actually been added or not. And then drop them if we need to change the design again. And we've just got this rich text block just to be able to create the tables and do that. So we can do that at the REPL. It provides a quick means of using this this code at the REPL without having to kind of look through all the APIs. So you can just say, oh, I just need to create tables. I'll just execute this particular function, and I've created them, and I can drop the individual ones, and yeah, just provides a user interface, as it were, to using the application within inside the REPL. So the new code, as I read, create, update. So I've just created a little comment in here just to separate this out. If this does get very large, then we can use the comments to decide which sections of code we could split off into their own namespace, see if it's worth doing that. So for now, I'm just keeping them all inside the database access namespace. So we've got create record, and I've changed the order of these just because it makes it a little bit easier to use them. So I've changed the order of the arguments. So passing in database spec, then the table, and then the record data, and that kind of ties in with how we actually how we call the JDBC insert command, because we're passing it in, we call this with a connection, and we get the connection from using the DB spec, and then we give it the table, and then we give it the record data. So it's just a small thing, but I think it makes it nicer to have the arguments in the same order as we're actually using it in the function in this case. And we've done create record as a generic function. So we just need to pass it some specific SQL data. And there's also, so that's using insert, and there's also insert multi, which allows us to pass in multiple records. So we can create like a dozen records at once, just using this record data, which is a vector of new records. So you can pass in, so you can create one or more new records with one single SQL statement. So that makes it a lot easier to do like bulk uploading. You could put the insert into a transaction. I'm not using transactions here, I'm just using a connection. But you could have multiple inserts all wrapped up in a transaction, a bit like we did with the create database tables. So in the create tables, we create this little transaction. So it's just an extra wrapper around the JDBC commands. And so this is going to, this doseek is going around and executing a transaction for each SQL statement that we pass in via the table schema. So the table schema has several schemas that we're passing in. As we can see here, we've got the 3 schemas, one for each database table. And so the transaction is going to do all 3 executes in the same transaction, so they're all going to work. So we could do that with our inserts. We could create create record, create multiple records and do them inside so individual inserts and do them inside a transaction. But luckily, so next.jdbc.sql gives us this insert multi, and so we can still create just one kind of big batch SQL statement that will update with multiple records. And then we've got read and update and delete. So we'll have a look at those in a little bit more detail. Let's look at calling them. So we've got create record. We're passing in the database specification. In this case, it's the dev database, so that's just H2 we've got running. We're passing in the table name, so this is public. So we're using the full name of the table, so it's in public, and the table's called account holders. And then we're passing in a map to do that, to represent the record that we want to add. And if I've evaluated everything, yeah, there we go. So we've got a new record that's being created, and it's showing us the account ID that we are using, that we've created. I can go in and read the records, again, passing in the database specification, and then just a very specific, just an SQL statement. So we're not creating anything with our Clojure data structure. We're just basically passing in an SQL statement like we did before. So this is very similar to using exec. There's not much difference here. So we can get all of the values. And so that's returning a nice Clojure structure of the records. So we've got account holders, and we've got and each of these maps is a row, is a record in the database, and so we can pretty print those as well, so we can see them. Let's see, pretty print. Let's just print them. There we go. So this is a bit more pretty print. It's just a human readable output. So it's the same output, it's just formatted so we can read it a little bit better as human beings. And so each row is a map qualified with this account holders map. So we've seen this in our specifications. So we basically just tagging on account holders to the name of each of the keys inside the map. So this key really is account holder ID. And so looking at this, actually, I could simplify the names used in here. So actually get rid of account holder and just call this ID, because it's still going to be represented as account holders / ID. At the moment, it's account holders / account holder ID. So it's something to think about how best to represent the fields inside there for like different purposes. But you can see that it's got all the, I've just been calling this function several times just to generate lots of values in there. Boom, boom, boom. So we can use this to explore very quickly and play around with records just to make sure all our functions are actually working correctly. Let's get rid of that for now. And then we can also get specific. We get specific records. So where, so in account holders, where the first name is Rachel, and so we can use whatever table name we want, and provide a where clause. And so this case, where the first name is Rachel. And then, yeah. Boop. Cool. So that is simple read record. So we're passing in the DB spec and the query, and we're just running that query over the connection created from the DB spec. So read's very simple. Updates, we're doing the same thing, where we're kind of same thing as insert, more or less, except we need to find a particular record to actually update. So we have this where clause which we pass in as well. So we're passing in the specification, the table we're going to update, the data we're going to update the table with, and the where clause to find the particular record in the database that we actually want to update. So let's have a look at updates. Update a record, and let's change that because I already run this before. So we've got this update record. We're passing in the database, dev database, on account holders, and then we're going to update the email address. So this is a map. So we're going to update. This is a map of our changes that we want to apply. Here we've just got one value we're going to update, but we could have multiple values in here. And then we're going to update the particular record that matches where the account holder ID is this UUID. And hopefully I haven't deleted that from the database. So we execute that, then we can see that it's run, and we've got this update count 1, which tells us that we've actually updated successfully in there, and we can actually go in and look at the we're going to select. We could actually, if we create a new one, we can go in and select from count holders where account holder ID equals this really long number. There we go. Let's replace that. There we go. And so if we look, we can see, yeah, there we go. It's updated. It's updated the email address to update to. We've got 2 Ks in there. Oh, that's interesting. There we go. So updates work nice and simply. And it also helps us test our database design, see if we've got the right design, see if we've got the right kind of values as lookups as well. Then if we want to delete something, I think I've already deleted this. Yeah, I've already deleted that one. So if we're doing an update count, we get update count of 0 if we've already deleted something. But if I use a different, so if I use this one, boop, boop, boop. Oops, press the wrong button. There we go. So I've just deleted that record that I've created, and we get an update count of 1, just to indicate that, yeah, it's changed, it's affected 1 row in the database. So if we try and read this now, then it's going to go nothing. So it doesn't return anything because we've deleted it. But it's returning an empty vector, so it's still a legal Clojure value. But obviously there's nothing in there, so it's a nice easy way. We've got a Clojure data structure to check, just doing empty to see whether a particular read record has returned anything. There we go. Create read. So I've just done these for public accounts, transaction histories as well. Oops, there we go. Yeah, so they're all working pretty much the same. And we didn't look at the code for delete, did we? No, let's just have a quick look at that. I don't think there was anything particularly in there. So yeah, with delete, it's even simpler. We just need to pass in a table and a where clause, and it will go off and find the record using the where clause, and it will do a delete. So if we have a look at the delete that we did here, so we're passing in the database specification for the dev database. We're passing the public account holders, table, and then the where clause is just a map saying where the account holder ID equals that particular UUID. That's the record we want to do. So it really does kind of minimize how much SQL you actually need to write, and it's unless you're doing a lot of SQL all the time, then it's kind of a really nice approach to try and minimize that. Okay, any questions? No questions? No. There we go. And what the next thing I want to try now, because we've got these maps, then the next thing to look at is, well, we could actually, in theory, we could use the database specifications to generate code for us as well. So rather than doing hard coded types, then we can actually get Clojure spec to generate these for us. So if we have a look at the specifications banking code we did, let's come back to that. So this is it's a namespace we did a while ago in this project, and it's using Clojure spec alpha, and Clojure gen to do generation of mock data or generating data that we can use for tests in our code. And so we've got all the specifications. Oh, this page down here. But then we've also got the section on generating data from these specifications. So I've evaluated the whole namespace. Let's just do it again. Boom. So I can use the specifications, so we can just generate random data from here. So it's generating here the sample command is generating a range of values. So it's creating a sequence of first names, and so you can see it's generating some very interesting combinations as well as empty combinations. So each time you're using this, it's generating new data for you, a new data set. So by default, I think it's generating like 10 sample data. You can also get just one, and you can also specify how many data sets you actually want as well. And so it's a really nice, simple way to generate information. So we've got all the single pieces of information, but then we've also got customer details. So we generate this and we get a nice sequence of all the different specifications that customer details uses, because customer detail is basically a collection of all of these pieces of information. And then account holder is all these pieces of information with a particular unique ID, which I'm not sure if we actually eventually will need. So using spec gen in here is useful during the REPL development. So what we could do is at the end of this namespace, we could actually create a function for mock generators. So here we're generating specific is a function that will just basically generate a sample of the customer details, and then if we go back to our if we go back to our database error, database access function, namespace, sorry, then we can go and use this mock data generator. So a few things we'll need to do is we need to include mock customer details in the namespace. So if we go here, we can just go in and add an extra require, because we're not using the Practicalli specifications banking yet, so that makes it available. We could give it an alias as well, but I'm just going to leave that for now. Oops. So, and then evaluate this, and we can then start using the functions and the specifications that we've got in that namespace. There we go. So we could do, we could basically call, we could call the Practicalli specifications banking mock data customer details, and this will generate some data for us. And so this is generating kind of a maps with the kind of sample data in here. So it's generating a sequence of them. So you can see each one's qualified by the domain that the specification is from. So we don't need that, but we can get the map data from there and use that to test our database tables designs to make sure that the data that the schemas are generating are going to work inside our database tables, and it will help us understand if we need to put any constraints on the database, on the data that we're using with our particular databases. So that's something I'm going to set up next, and we've started doing that a little bit, but I haven't quite finished that yet. So it's going to we're going to add that into the Clojure spec, generating this and using the so basically going to grab the maps from the specs and use that with the insert records and then generate basically have a little mini database test suite to run and generate a whole bunch of random data and insert them, update them, and so on. Might need to still do some specific ones that will actually go off and find a particular record, but this is, it kind of sets up for generating a very simple kind of approach to having a little test suite for like working with the database, just to make sure that we've got the design right and we don't find any kind of edge cases, which is better to do now than when you've got your design, your database design in production, which is a little bit more trickier to work around. Okay, I'm going to leave it there, and if you want to play around with kind of generating specs, then that's already doable. So you can have a little play and experiment before next time to see if you can come up with some interesting ideas yourself. And then we'll also look at things like HoneySQL, and then once we've got the mock data put up, then I think next time we'll also do wiring up to the database, wiring the database functions, calling them from the handlers. So I'll do some work on that for next time. Okay, well, if there aren't any questions, I'm going to leave it there. If you want to reach out to me, then the Practicalli channel on Clojure in Slack is probably the quickest way. Or you can send me a DM through Clojure in Slack as well if you don't want to ask in public. There's plenty of content ideas on all of the books. So if you have any interesting ideas you want to see, then feel free to browse through. So like some of the ideas I'm going to put into the books, or go in and actually go and add something. It's just using GitHub. So these are just GitHub issues. So you go off and create a new issue, or you search for issues. So all the spec issues, things I'm going to add there as well. That's another way to kind of help them. And if you see a bug as well, you can raise issues on there, raise a new issue and say, oh, there's a bug on this page. Okay, well, thank you very much for listening, and if you have no questions, feel free to reach out during the week. I'll be doing some more work on the banking on Clojure, and also the new changes coming up to the Clojure CLI tool, and lots of other things that are happening in the Clojure world as well. Thank you very much for joining me, and see you next time. Thank you. Bye-bye.